Okay guys, pretty quick video on mean and standard deviation of binomial distributions. Fairly easy. It's just mean looks a little bit different than what we're used to. So if account X has the binomial distribution with number of trials n and probability of success p, the mean and standard deviation are now going to be given with the following formulas. So for the mean, we're just going to multiply the number of trials and the probability of success. And standard deviation, a little bit more work to be done. Of course, we have the square root involved here. And then the mean times 1 minus the probability of a success. So let's take a look at a quick example. Mr. Bullard's AP Statistics class did a taste test to distinguish the difference between bottled water and tap water. They were given 3 cups, one with tap water, one with bottled water, and the last was a truth cup. So there were 21 students in the class. If we assume that the students in the class could not tell tap water from bottled water, then each one was basically guessing with a 1/3 chance of being correct. Let X equal the number of students who correctly identified the cup containing the different type of water. So let's first talk about why we know it's definitely a binomial random variable. So we have to go through bins. So binary, you could definitely identify a successful outcome being the number of students who made a correct identification. Failure would be the number of students making an incorrect identification. So it's definitely independent. What one is going to say is not going to change the next guess. What one guess would be wouldn't change the next guess. Number of trials, it's 21, and the probability doesn't change from 1/3 on each for each student. Okay, so there were 21 students. Oh, okay. So now we're just going to find the mean and standard deviation. So let's first talk quickly about the mean. And I say quickly because quite possibly we couldn't be given any easier numbers here. So the mean is 7, okay? Number of trials, 21 times the 1/3 was your probability here. So on average, after many trials, you would expect on average 7 guessing correctly. Or I shouldn't say guessing correctly, I should say identifying correctly. And now for the standard deviation, we have number of trials times probability times 1 minus the probability. So that's going to be 21 times 1/3. 1 minus 1/3 is going to be 2/3. And I'm just going to straight put this into the calculator, and I get 2.16. So what this is saying is that after many trials, the number of correct identifications would typically vary from the mean by about 2.16, same as we always interpret standard deviation. Okay, so there were, of the 21 students in the class, 13 made correct identifications. Are you convinced that Mr. Bullard's students could tell bottled water from tap water? And we're going to justify our answer. So essentially, we want to know what's the probability. Oops, not yet. Okay. What would be the probability of students correctly identifying would be greater than or equal to 13. So this is a case where you wouldn't want to say add together all of the other situations. So you don't want to do the probability of x equals 13, the probability of plus the probability of x equals 14, because you got to go all the way to 21. And so your best bet is to put it in relationship of your less than or equal to, because we have a function on our calculator that will find that, or a binomial CDF. So we're going to do 1 minus the probability of x being less than or equal to 12. So that would be equivalent to x being greater than or equal to 13. So in the calculator, I'm going to put 1 minus binomial CDF, and we do the number of trials times the probability, and then our x value, or k value, if you will. And then this would be 1 minus 0.9932, and that's going to give me 0.0068. So that's about 0.68%, okay? So because they're telling me that the probability of 13 or more guessing or identifying correctly is as low as 0.68%, I would say, yeah, I'm pretty convinced that Mr. Bullard's students can absolutely tell the difference between tap water and bottled water. Okay, guys, so now you could check your understanding. You have it in your notes. Get down your answers. I'll be taking a look at them, but we will check them in class.